Hello everyone, welcome to our channel CodeChef. I am Kusmulata Bhatt and today we are going to solve the problem 2-number game from CodeChef platform. It is of Cakewalk difficulty level and it requires no prerequisites. So let's understand the problem statement first. So here the first two lines are simply the introductory line of the problem which says, hey, welcome to the competitive coding event of Code Blasters. So let's start with the warm-up exercise first. So here the problem says Chef is a master of 2-number game and Chef wants you to play this game with you as he has nothing to do due to COVID-19 lockdown. The game is simple. Chef will give you two numbers, let's say A and B, and you need to tell whether the given two numbers can become equal after performing given operation. That is, incrementing A by 1 and decrementing B by 1. And note, you can perform the given two operation any number of times. So what we have to do, we are given with two numbers A and B and we have to make them equal simply, and we are given with the two types of operation in which we can increment A value by 1 and decrement B value by 1. Now before solving the problem, let's see the input format first. Now the first line of the input is going to contain a single integer t which is going to give us the number of test cases, and then the description of each test case will follow. So for each test case, we are given a two space separated integer a and b, which is going to denote us the number given by chef. Now for the output terms, we have to simply print yes in capital case if it is possible to make a and b equal, and else we have to print no. So now let's have a look on the constraint. And the constraint for the problem is t value is going to lie between 1 and 1000. A and B value is going to lie between 1 and 10 to the power 6. So let's see how we can solve this problem. So we are given with two values A and B and we have to make them equal, and we can use one of the above operation any number of times. We can simply increment our A value by 1 and we can simply decrement our B value by 1. So let's see when incrementing our A value will actually help. So we will be incrementing our A value by 1 only when incrementing it make us sure that we are reaching one step closer to B. And this will ensure when our B will be greater than A, because only then on incrementing A we are making a step closer to B. If our A would have been greater than B, then incrementing A would not have made any sense. We would have been only increasing this value, which will be turning A more and more greater than B and will not be reducing the difference between the two. So this step only makes sense when the B value is greater than A. Now similarly for B equal to B minus 1, we can say that we will be only decrementing our A value when the A value will be smaller than B, because only then we will be reaching one step closer to A. When A will be greater than B, then decrementing B by 1 will only be increasing the difference between A and B value. So we can say that both of the operation are getting applied on the situation when A is less than B. Because for A greater than B, so hereby we can claim that both of the steps are only useful when A is less than B. Whenever A will be greater than B, then these steps are only going to increase the difference between the two values. Now the one case remains in which A value will be equal to B. So we can say that it is a trivial case. For this case, answer is always going to be yes, because we can not apply any of the operation above and we can achieve the situation when A and B is equal to each other. As we are not given in the problem that we have to apply the operation at least once. So we can say here that we are not going to apply any operation in this case. So from the above, we can conclude that if A is less than equal to B, we are always going to achieve our answer. We are always going to achieve the situation when A equal to B by applying 0 or more times the number of provided operation. Or if A is greater than B, then we can never achieve the situation A equal to B. So let's see the input test cases. So for the first test case, we have A equal to B and B equal to 7. Since A is less than B, so we can simply achieve this situation by applying 2 times first operation here, or 1 time first operation and 1 time second operation, or 2 times second operation here. So we can achieve this simply. So we can output yes as the answer here. So now for the second test case, we have A value as 10,000 and B value as 5,000. A is greater than B, and applying any of the above operation any number of time will only increase the difference between the two. So we can say here the answer is no. They are never going to be close to each other. And applying one of the above operation here will only increase the difference between the two. So let's see how we can implement our solution. So first we will take the input of t, which is going to give us the number of test cases. Then for each test case, what we are going to do, we will take the input of a comma b, and then we will check the condition. If a is less than b, then print yes to the screen, or else print no. So the time complexity of this, so the time complexity per test case will be O of 1, because here we are simply doing the constant number of operations. We are first taking the input of A and B, and then we are just checking the condition and printing the output string on the, and then printing the output to the screen. The space complexity is also going to be O of 1. Here again we are using the constant space for storing the variable t, a, b. And the space complexity of the solution is going to be O of 1, because here again we are storing the constant number of variables. So let's have a look on the C++ implementation of the code. So in the sixth line, we are declaring the variable t, and then we are taking the input of t. Now we are running the loop for every test case here, and for each test case, what we are doing, we are simply taking the input of a and b, and we are simply applying the condition that if a is less than equal to b, we are going to print yes, or else we are going to print no. Now let's have a look on the Python code. In the Python code, again the first step is taking the input of test cases. Now for each test case, we are taking the input of A and B. Again, we are applying the condition check that if A is less than equal to B, we are going to print yes, else we are going to print no. Let's have a look on some of the common mistakes that we can make during this problem. So for the yes and no problem, the major mistakes we make is we simply forget the case of the yes and no, which we have to print in the answer. Like in this answer, we have to print yes and no in the uppercase letters only, but here we are using the different case. So we have to make sure that we are printing A and B in correct case. So that's it for the video, guys. Thanks for watching.